Uh, Greetings, everyone, and welcome to a day in the life of a threat analyst, a technical case study on, the best way to put it is, who done it, or a more political way is a threat actor attribution. Thank you for joining, and I'm not going to say good afternoon because I know we have audiences from UK, Europe, Americas, and Asia, and the Middle East, so welcome, everyone. We're going to dive straight in. There is quite a lot of material to cover, several survey questions that we want you to participate in. Do remember, this is an interactive webinar also, and you can ask questions with the question button. Also, one final request, switch off your mobiles, you know what I mean, although I can't hear them. But also do leave feedback for the actual webinar towards the end of the session. So we're going to go straight in. A bit of what we're going to cover, alternative titles that I think people have told me my trademark, and we're going to do some introductions, the role of an intelligence analyst, the young man we have here who's going to tell you everything that he does and not tell you everything that he does at the same time. Typical challenges and questions, tools, and case study. This is your chance to ask about additional tools. Okay, you don't get these kind of folks online every day, and even though you get me every day, but I don't have the time to answer all of those kind of questions. So moving forward, alternative titles. Not another threat analyst webinar. No, this isn't one of those. This is way more informative. That's one of the alternative titles. Another alternative title is Uncovering the Secret Life of a Threat Analyst. And just in case you're wondering who that is, you can see the tiny little photo, which is soon going to be enlarged in a few minutes. This chap on the left could be a threat analyst, but he's too busy taking cards away from people. And with the current no name 140 million attack, so he's too busy. He's not a threat analyst. But the guy on the left, he's definitely a threat analyst. I haven't met him physically, but I know he's a threat analyst, and I know the people who work with him, and he's going to introduce himself very shortly. And then moving on to introductions of who the presenters are. This is yours truly, the one on the right, wearing a blue turban. That's myself. I'm the founder of Cyber Management Alliance, Give One Day, Wisdom of Crowds. I love what I do. I'm the creator of UK government certified training courses in incident response, privacy essentials, etc. I'm still a CISO. I'm a practicing CISO. I've been one. And I just love cyber and love threat analysts, which we're going to talk about now. And introducing himself now with the motorcycle. Imagine him on the motorcycle. It's going to be Mr. Miller. Steve, over to you, sir.
Hey, what's up? Thanks, Amar. What's up, everyone? My name is Steve Miller. I'm an intelligence analyst with a small Bay Area company called Anomaly. And I guess the reason that I'm on this call today is to provide an expose, the type of work that a threat analyst does on a day-to-day basis, and hopefully, you know, that will give some insight in maybe my role and the challenges and the types of processes that people like me typically go through to do their work. So you can see all the logos, a little bit of background about me. I live in a small town called Ithaca in central New York. I started my career off in the U.S. military. I lived and worked at the National Security Agency at Fort Meade, where I focused primarily on the signals intelligence space. So none of the cool controversial stuff that you read about in WikiLeaks, but more things to do with intercepting and extracting information out of wireless comm systems, like cell phones and radios and stuff like that. I moved on from the NSA. I worked at Cornell University doing IT and security systems stuff, and then in the computer forensics, where I did some projects for the U.S. State Department and the U.S. Department of Homeland Security. And then in 2013, I kind of cut my teeth in the incident response space by going to a company called Mandiant, which does enterprise incident response from a consulting point of view. And all of that background is kind of important because it kind of speaks to my biases. You know, I've spent many years fighting enterprise intrusions by, you know, a lot of Chinese and Russian and other state-sponsored threat actors. my role is a technical intelligence analyst rather than a strategic. So my focus is on, understanding the tools that the bad guys use, looking at, the bits and bytes and the packets to get an understanding of who they are and how they operate. So that's the gist of it.
Excellent. And for those who are going to try to be a bit, you cannot ask Steve any questions about whatever he did in the three-letter agencies. So don't dream about it. If you do ask those questions, they will be ignored, and we carry on. But Steve, and one more thing, this is going to get a technical, this webinar. So if you don't understand it, it's fine. You can always research it. But for those who do understand technical stuff, you're going to enjoy this really quite a lot. And Steve, thanks for the introduction. So we're going to go straight into it. What does a threat analyst do? And this is the image I found. It's like trying to figure out, what do you guys do? And before I give it to you, Steve, I mean, my experience, a lot of the time, people who are not experienced threat analysts spend a lot of time figuring out who's done it, right? And what are your thoughts on that?
Yeah, my impression is that really good threat analysts typically have experience working a lot of intrusions. That's how they're able to figure out who's done it. I think the biggest things that a threat analyst really does is interpret different types of intrusion activity, and help gather context and related information to see if that intrusion activity is a big deal or not.
Excellent. So take us into exactly what, I mean, I know there's quite a lot of material to cover, but we only have about 55 minutes. So what does a threat analyst do? And then we're going to go deep dive into more of what to do. Over to you, sir. Yeah.
All right, great. Well, so yeah, like I said, I think a lot of the role in terms of what threat analysts do, or intel analysts, and I use those terms kind of interchangeably, is to kind of work with security operations people to help them understand what they're seeing in their instrumentation. For example, they see some alerts and they have to wonder, what do these things relate to? And so the role of the threat analyst is to take intrusion data and kind of pass judgments on areas of uncertainty, all of which leads to kind of assessing a risk and maybe making recommendations about what to do to either mitigate that risk or reduce that risk somehow in the future. So, again, starting with more atomic indicators, which, being the kind of smallest pieces that you might see, either an IP address or a domain or maybe a sample of malware. And you have to wonder, okay, what malware family is this part of? Is this backdoor, is this specific to a certain threat actor or not? And the reason that's important is that the answers to those questions can significantly change how a responder responds to a given event. So you have to be able to establish relationships between atomic indicators and threat actors.
Steve, for those who in the audience who may not know, what is an atomic indicator?
Yeah, an atomic indicator, and I think a lot of people will say IOCs more abstractly, but atomic indicators to me are just, they're really just small pieces of data that out of context don't really mean much. If you have an IP address, it's just an IP address. So that's the smallest atomic indicator, and when you want to make that a more rich piece of data, you have to attach some context to it and explain what it's associated with.
Excellent, and hence the word atomic. So before carrying on, Steve, I want to, there's several questions. We want interaction from the audience. So the first question, survey questions, please do share your input, is my company has a fully functional threat analysis department. And I'm going to click start voting. So please do give us your opinion. It's a simple yes or no. My company has a fully functional threat analysis department. And we'll carry on. Steve, atomic indicators, how do you put the context around this then?
It's a good question, and I think everybody kind of has their own approach to gathering context. But my basic process always starts with aggregation of those IOCs. So I think the three most important ones for threat analysis are domains, IPs, and hashes. And my basic approach is to kind of cluster those together, and then first to try to attach or associate those with code families, which are actual pieces of malware or malware ecosystems. And after you can make an association with a code family, then you can start to think about who is behind it in terms of the threat actors.
And again, I'm maybe speaking on behalf of the audience also. So someone would say, is there a code family database that sits somewhere on the internet that that you use, I guess, that is accessible to the public?
I wish there was. I think maybe the closest thing that comes to it is something like MITRE. The company MITRE has like a wiki. It's called the Attack Wiki, which is kind of a good reference for tools and malware families. I think a lot of vendors will publish reports for the different malware ecosystems along with atomic indicators that can help serve as reference for those things. But I think a large part of the job of the threat analyst is to build a knowledge base of all that disparate information in order to make sense of it.
And is it correct to say that in some cases or many cases, one code family is called something else by multiple vendors? Is that right?
Yeah, that's actually the worst. That's the worst part of it, is that a lot of security vendors who are basically just falling all over themselves for public attention will publish reports with their own threat actor names and their own malware family names, and they're actually adding more confusion rather than clarity surrounding the threat issues. So I think the big job of an intel guy is to reconcile the public knowledge, especially between vendors, because what defensive operation doesn't have multiple vendors as part of their infrastructure, right?
Totally. So we've got one question just popped in. Is a threat analyst involved in reviewing and updating threat analytics orchestration platform, automating the remediation? That's quite a mouthful. Is a threat analyst involved in reviewing and updating threat analytics orchestration platform, automating the remediation? Do you have any answer, or maybe shall we park this and come back to it?
I would say, in short, it depends, like everything. I think a lot of threat analysts will have a role in those types of things, but maybe not be responsible for it entirely.
Okay, so we've got to move on. There's quite a lot of stuff, a lot of material to cover. For those who took part, 61% of those who took part say, my company has a fully functional threat analysis department. 61%. Wow, that's impressive, but 38% have said they don't have a fully functional threat analysis department. So a few more seconds and we'll stop voting, and then we have another question to the audience. Another survey question. So we're going to stop voting there, and I'm going to put forward another question. It would be useful to have immediate insight about a ransomware, and what I guess that question means a bit more is insight about the code family, who's done it, et cetera, et cetera. So the question is, it would be useful to have immediate insight, who's done it, who the actors are, about a ransomware. So this is open to the audience. One more question, Steve, is, are there other tools to conduct threat analysis modeling other than Microsoft threat modeling during development lifecycle? Okay, we shall park this and then we can come back to this. Okay, Steve,
yeah, I think we'll answer that question as we kind of move forward.
Yeah.
So as I was saying, tying code families to threat actors. I think that's kind of one of the big jobs in terms of assessing risk. as far as that's concerned, you know, the reason I think that's important, and I try to illustrate this in many ways as possible, is that, you know, it's really good to know who's behind it, because all threats are different, right? And the way you respond to things in defensive operations are different. So, for example, you know, I described this one malware family, HOW123. It's a piece of adware. It's one of the largest pieces of adware in the world, over 100 million installs. I described that as yeah, more probably. I think it was closer to 200 or 300 million last time we looked. But it's such an annoyance, but it represents a very low risk to an infected system, right? So how you respond to that, you know, you may even just leave it there because it doesn't really do anything to the system except redirect traffic from a home page to a different home page. But you know, you might receive a security event based on that malware family. But again, it's a very low risk. And so I describe that as having a mosquito in your house. You can simply squash the mosquito and go about with your day. Whereas if you have an alert that is, you know, by the malware family Cozy Car, and it's related to, you know, a threat actor APT29, well, this is indicative of something that might be much more worrisome. You know, the risk of catastrophic impact is much higher. So when you're going and doing an incident response for this situation, there are a lot more actions that you have to take in order to reduce the risks of you know, again, something really bad happening to your company.
So here's a question. Is this something that you are maintaining? Is this something that someone, I'm sure many of the viewers are thinking, could they get hands on all this hard work? Is this something that's unique to you?
You know, like this type of, I think this is a way that a lot of, you know, intelligence vendors and intelligence analysts will kind of classify things that security events and detections in general. So, for example, if you have some sort of security appliance and an event fires, a lot of them will be able to tell you what malware family this relates to and maybe what sort of risk this represents. But again, there are some situations which may require a deeper or more detailed interpretation of that information.
Excellent. This is really useful stuff. So just briefly, 95% of those who selected to vote, it would be useful to have immediate insight about a ransomware, which is similar to what I think you and I have discussed. Next one to the audience is, my company currently subscribes to paid threat intelligence feeds. Question for the audience. My company currently subscribes to paid. It could be a little bit of money, it could be a lot of money, to paid threat intelligence feeds. That includes IOCs and etc. So that question is open for the audience. And Steve, we've got other questions here which we may also have to park and take it as we go on. How does a malware program such as Norton, anti-malware program, I guess he meant to say, I don't know, or is it, maybe I'm reading it wrong, to fit into the code family, repository, or naming? Are the bigger companies relied on to do the naming of the malware?
In my opinion, again, just one man's opinion here, a lot of the typical antivirus companies apply very broad names to huge sets of malware. Right. And so, you know, a company like Norton or Chun Micro or ESET, you may get detections on things that, you know, again, are a blanket for, you know, hundreds of millions of pieces of individual samples of malware. So I think it's kind of hit or miss in terms of how antivirus programs will detect things. And in my opinion, you often have to look for more detailed descriptions to get exact code families.
Excellent. We're going to go to even more exciting stuff. And a reminder again to all the audience members, do please contribute to the survey. It just helps build a good picture of who is online and what they feel. So we are now going to go, Chris, into the case study that we've put together. Over to you, sir. Very interesting case study.
All right, let's do it. So anyway, again, I'm always kind of doing analysis for different people. A few weeks back, I got a request to do some malware analysis, and the customer provided me some malware samples and a couple of IOCs. And at the core of the request was, the customer wanted to get a better understanding of the malware, and then the secondary request was kind of to see if we could classify it and connect it with a threat actor. And ultimately, we connected it with the actor publicly known as Wet Panda. So I call this kind of a Wet Panda intrusion set that we studied here today, and I'll kind of walk through some of the details.
Excellent. Here. That's the only image we could find, so we couldn't find a panda bathing legally to use. So could be a dry panda, but for those, yeah. But the actual threat actor is called Wet Panda.
Yep. And so so here's kind of, I'll go back. We'll start from where we first initially got it. Customer gave us a malware sample, and again, we wanted to see what the malware was capable of. The customer did not know, what sort of C2 domains it called out to, or if the malware wrote to specific registry keys. And these things are important in terms of, the customer's ability to figure out if this thing is detected in all of their various kind of defense infrastructure. And they could use that knowledge after we did malware analysis to better understand the full scope of the intrusion activity that they were seeing. So we go ahead and, we started to do malware analysis, and this kind of goes into, the first things that I always start out malware analysis by leaning on my automated tool sets, because nobody has time to manually debug every single sample they get or to do disassembly. So you kind of look to the tools to do, some of the heavy lifting for you. And there are tons of tools out there. I've listed here some of the ones I'm fond of, but basically all of these sandboxing technologies do some form of virtual execution on a malware, and they log its functionality to determine what it's capable of doing on an endpoint.
And obviously, this is just a reminder to everyone: do not try to, take and inspect malware on a corporate machine. Use sandboxing.
Yep, that's a good point. Yeah, a lot of these, like Cuckoo is an open source sandbox, and then Joe, Cisco Threat Grid, FireEye AX, VMware. These are all kind of more corporate solutions that you would buy either a cloud subscription to, or maybe some sort of on-premise gear that you could do like bulk analysis of samples.
Interesting. So sorry, just sticking on this for a second. The open source one you said was Cuckoo?
Yes, Cuckoo.
And is that enough for someone who is listening in to start on the journey of, learning about how do you dissect a ransomware?
Yeah, I think Cuckoo is a great spot, and a very capable. It's probably the best open source solution for sandboxing. It's easy to download and install and execute these different pieces of malware and kind of see how they behave. And
without
interpreting, without infecting your own system, and then you'll be able to kind of get a better understanding of what these pieces of malware look like when they're executing.
Excellent. Quick one. My company currently subscribes to paid intelligence feeds. 52% of the audience who took part said yes, that their company subscribes to threat intelligence feeds. My company has all the necessary systems and processes to ingest threat intelligence feeds. So subscribing is one thing. The question now for the audience is, if for those who said yes to pay or not paid, your company has all the necessary systems and processes to ingest all the stuff that you get. Sorry, carrying on. So Cuckoo, we've discussed. Some of them are paid sandboxing technologies, like FireEye.
Yeah. A lot of these, you would either buy an on-premise appliance, or maybe you would buy access to a cloud account where you could kind of upload it through your browser, and then the analysis is done in the cloud and kind of presents you a view of the malware execution.
Right, and this client gave you this piece of code, and you loaded it into what you have on your screen now is VMware.
Yeah, basically, the customer gives me the malware samples. So of course I use whatever tools are at my disposal. In this screenshot, we see a sample of a VMware solution, which is a agentless hypervisor engine. It's probably one of my favorites that I've ever used, because sometimes a piece of malware will have anti-analysis capabilities built in, so it knows when it's in a sandbox, and if it's sandbox aware, it may not execute fully, and you won't really get the insight that you wanted out of that sandboxing run.
Right. But this VMware manages to fool a lot of that?
Yes, and they call this an agentless hypervisor solution, but basically how it monitors the actual malware execution isn't inside of the virtual machine. It's in the hypervisor, which runs multiple virtual machines inside of that.
I understand. So could you take through, is there something here that you can share? Okay, the next right, you're on the next screen already. Okay, good.
Yeah, basically when I'm looking at these sandboxing reports or these are things that I would also do when I'm manually analyzing a piece of malware, is I want to know, what files does it drop or write to disk, as well as what it's kind of looking at, because that gives you an idea of what sort of information it wants. Maybe registry keys or persistence mechanisms. So for example, if it copies itself to a startup directory, or it installs a service, these things will give an indication of what it's capable of. Domains or IPs that it calls out to. Maybe if it initiates a certain type of HTTP request in its network communications, that would be useful for assessing your detection posture. Any sort of process behavior or unique strings or functions. These are all things that, as a malware analyst, you want to know these things so that you can fully understand and classify, the piece of malware that you're looking at.
So, Steve, I want to kind of touch a little bit on persistence, right? Because as you know and I know, yes, there's fileless malware gaining foothold, but persistence is still one of the key things that most cyber criminals are looking for, so that they can then come in when they are chilled out or whatever, or they can sell that access onwards, right? So as a threat analyst, are there key, attributes, key things that you would look for? Because to me, persistence is really important, and if I can deny persistence to a malware, I feel I'm on the winning side. Am I making sense?
Yeah, I couldn't agree more. I think persistence mechanisms in general, especially, my background is primarily in like Windows ecosystems, but there was a study recently where I think like 60 or 70% of like malware was using either Windows services or sort of the standard auto runs for persistence. And these are really interesting, and they're easy data sources to look at. And if you could either look at these data sources continuously or deny access to these these areas of the environment, you would very easily inhibit a huge portion of the malware that's kind of out there in the wild right now. So I couldn't agree more. I think persistence is probably one of the most crucial attributes for denying.
Is there a giveaway when you're investigating this, the malware? Is there a giveaway, or is there something that you are going, oh, that caught my eye, that's it's going to demonstrate persistence behavior? Am I making sense in my question?
Yeah, I think what you need to know is familiarity with all the different persistence mechanisms. So for Windows, there's like a limited number, and there are some that are very common, but I think there are about 150 total persistence like ways that a binary can persist on a machine, whether it's malware or not. And by familiarizing yourself with those ways, when you do the malware analysis, you're able to say, oh, well, it's copying a file to this particular register key. I happen to know that that's going to enable it to be there upon reboot. Very
insightful, folks. So 150 odd ways, not that many. If you can't sleep, I'm sure you can remember them. But it's good to know 150 odd ways which is still a limited, yes, it's 100, but a limited number of ways, methods that a malware can use to gain persistence. Very interesting and insightful. Excellent. Sorry. Yes.
And
next one.
Yep.
Mm-hmm.
And then I guess when my automated kind of solutions maybe don't give me the granularity of detail that I'm looking for, most analysts and malware analysts will have their own virtual machines that they provide quarantine sandboxing for. So you execute your malware in the virtual machine. You have your different tools, debuggers and PE kind of tools to look at the static and dynamic values that are generated by the malware when it executes in your own little personal sandbox.
Okay, let me just come back to that. Give me 1 second. So quick response to the survey, 28% say my company has all the necessary systems to ingest threat intelligence feeds. Another quick question on this is we feed the threat intelligence feeds, we see what that means, into SIEM systems. So again, let's have some feedback from the audience. How many of you feed your threat intelligence feeds into your SIEM? I'm sure they're still called SIEM systems. So, sorry, carry on. Steve, can you expand a little bit on what's on your screen now, for those who may not know?
Yeah, right now, this is a screenshot of my own personal analysis virtual machine. You see I've got dozens of tools kind of up and running. I take a snapshot, and then what I basically do is, I'll execute a piece of malware, and then I'll observe its behavior while it's running. So I look at, on the right side, I have Process Explorer kind of up and running, so I can see when new processes are created just after I've executed the malware. And then I'm also running something called FakeNet, which hooks all of the network traffic, so I can see if there's a call out to a malware domain or IP, and kind of where the malware is intending to speak to.
So basically, can I just expand on this, right? For those listening in, if you have not done this before, you do need to understand several technologies. You need to understand a bit of networking, IP addressing, how DNS servers work, how a little bit of coding works. Am I correct? There are multiple things. Does a threat analyst need to be a jack of many aces? Is that the best way to put it?
Yeah, I would say there's elements of malware analysis. You have to understand all the different types of networking technologies. You have to have an understanding of a lot of how the actual operating system works as well, because you're marrying all these different pieces of data together to get an understanding of what's going on.
Interesting. So it's not that straightforward, I think. So, it's best to, for those obviously listening in, it's best to have a grounding in many different technologies, because as you are saying, Steve, there is so much that needs to be pieced together to figure out what is happening. So you have Process Explorer there. What else is there? Sorry, I'm just trying to see what else is there. You got FakeNet.
FakeNet, Process Explorer, a lot of debuggers like Ollie Debug. When I get into disassemblers, I think everybody uses IDA or IDA Pro, which is like the standard disassembler. And of course, hex editors for when you need to look at, the bits and bytes behind the different pieces of data that are written to disk.
Excellent. So before we carry on, SIEM, 60% of the respondents say they feed threat intelligence feeds into their SIEM systems. I'm only stopping because we've got a few other questions. The next one for the audience, threat intelligence from the correct or right source is crucial in defending against new and emerging threats. This is an opinion, I guess, and hopefully the audience agrees with us, but let's see what the audience says. The question is, threat intelligence from the correct right source is crucial in defending against new and emerging threats. Steve, over to you, sir. Yes, carry on. What comes next then?
So basically, back to the story in terms of me analyzing the malware. I did all my sandboxing. I did my sort of human analysis. And we're still kind of determining what the malware is capable of doing. So after analysis, we saw that w.dat, which is the sample we're looking at, it contained a cab file, which is a Microsoft cabinet file, kind of like a zip file, but basically it contains DLLs and then pieces of shellcode, which would write to disk along with a batch file, and the batch file helps determine how these other files would interact and execute together in order to install and make the malware persist on the host. So again, we're kind of getting a better understanding of just what this malware is capable of doing, and then we want to use that understanding to figure out, to classify it in what code family it's part of.
I'm going to put you on the spot here. Is there something a threat analyst should not do? Is that a good question? What should a threat analyst avoid doing?
I think there's a couple of things. One, I think there's the ability to go down the rabbit hole. So like you have to know when you know enough, so you don't commit too much time. And another thing that's important while you're doing research on these things is you don't want to tip off the attackers and let them know that you're kind of researching them or studying them or responding to them. So you call that the concept of operational security. I want to be really careful while I'm researching this malware, so I don't want to tip off the attackers too soon before they know, while I'm still gaining context around the incident.
But okay, now hear me and stay with this concept, right? But surely you need to talk to your peers, right? Now, how, is there a platform that you use to communicate saying, hey buddy, hey Amar, found this, can't figure out what's happening here, do you have some insight? Am I making sense in my question? Is there something you do?
Yeah, this is communicating certainly within the greater threat intel community, as well as within your own peers inside of your company. I think there are ways you want to share important information around the threat, but you don't want to give away too much, particularly because intrusions are sensitive.
So are you saying it's a very lonely life of a threat analyst?
It certainly is, in a way. It certainly is.
Okay, very interesting. Excellent. So what happens next, sir?
So after I've gotten kind of information about this malware and I've done some analysis around what it's capable of, the next thing I really wanted to do was kind of expand my understanding of the intrusion set. So I wanted to find all the related malware that were connected to this initial sample. So we call it, our initial sample is the unknown sample. And one of the things I noticed is that this had very unusual DLL exports. So these are functions that are provided to the system that it's installed on that are not native to Windows. So it's providing additional functionality, and these kind of had weird exported DLL function names. And so I wanted to use these as unique tool marks to kind of figure out, are there any other samples of malware in the world that use these particular DLL exports?
Yep, and then you go to VirusTotal, I guess. But before you click next, buddy, what's the program that you have up there on that screen, up here?
Oh,
oops,
sorry.
Sorry.
Yeah, I got it. Yeah, the program was PE Studio. Basically, this is something that lets you analyze the static structure of an executable. So every PE file has a certain an import table, and it tells you the different sections of resources that are inside of that. And by exploring that, you may be able to kind of suss out interesting or unique kind of tool marks of the malware.
Excellent. So yeah, sorry, moving on. Went VirusTotal.
Yep. So next, once I have these exports, I kind of my biggest favorite things to do is to go to VirusTotal Intelligence and kind of search around in this huge repository of malware and say, are there any other things in the world that use, these particular exports? And immediately I can find additional samples. And so, I'm able to, this is where I begin to start to build a little cluster of similar malware, that's going to help me classify it.
But would it be correct to say then surely malware developers are also kind of checking with VirusTotal to make sure that they don't show up on here?
Yeah, that's absolutely a thing. I think there's there's a big component of, one, bad guys will upload their malware to VirusTotal to see how detected it is. And you'll notice in this screenshot, like both of these malware have very little detection. 1 out of 65, of the engines, which is remarkable. Like that's exactly what they're shooting for. Yeah. And then the other thing is that a lot of people who are experiencing intrusions, they'll upload this stuff to VirusTotal as well because they want to see if it's detected by all these antivirus engines as well. Right. And then you have like major integrations between some of the AV vendors. When they have a heuristic detection, it will automatically get uploaded to VirusTotal. So again, this is just like probably one of my favorites, and in my opinion, the best source of just raw malware data that there is.
Excellent. Very insightful. Let's move forward. Yep.
So, after I start looking around in VirusTotal, I'm also using, VirusTotal's graphing engine, and this is super new. It's basically in an alpha stage right now, but it lets you kind of pivot around and build a visual cluster of the data that is within VirusTotal. And again, what you're basically doing is building connections between all the different atomic IOCs, whether it be a hash and an IP address or other tool marks that are within the malware ecosystem in terms of how these things are connected.
Cool.
And then, kind of as this grows, and it's like this is where it's not sexy, but you kind of my process is to do things like, we call this retro hunting. Basically, I'll write Yarrow rules for different, different things in the files that I'm looking for to collect even larger clusters of kind of the similar malware family that I'm looking for. Again, I'm trying to classify this unknown family. So I'm looking for anything that's submitted in VirusTotal with the same file names. I'm looking for overlaps in import table hashing or maybe specific hashes of the PE resources. I'm looking for also anything that behaves similar in the VirusTotal sandbox, which is another aspect of VirusTotal, or also things that are submitted to VirusTotal with the same submitter ID, which is another way to kind of get a guess at what things might be related.
Okay, excellent. And then what happens after this then?
And this is where things kind of got crazy, or at least this is where I started to get a better understanding where this unknown family kind of played in. But I started putting all of this stuff in kind of a spreadsheet, right? And again, this is like, nobody wants to admit it, but like Microsoft Excel is like an amazing intelligence tool in a way, because it allows you to kind of chart. Nobody says that, but it's like, it's really true. Everybody comes back to it. When you want to look at kind of things stacked up against each other, this is like exactly how a lot of analysts do it. So I started to list all the stuff in an Excel spreadsheet, right? The hashes, the sizes, the file types, when these things were first submitted or compiled and their names and stuff. And one of the things I noticed was that there was a particular submitter ID. So every time you submit something to VirusTotal, VirusTotal tracks your submission based on a bunch of characteristics in your account and whatever with a certain GUID value. And if you are collecting all of this information, you can pivot on the GUID to look at all the files that a particular user has submitted. And so what I noticed was that there was an interesting cluster of malware that I believed was related to my unknown piece coming from a single submitter value. So I went ahead and I pulled all of that together and interpreted all of the malware that that submitter was putting in the virus total, and that was again kind of something that helps me build up this evidence for what might be related to my initial sample, which was what my customer was really asking about.
So all this great investigations, great knowledge, I mean, leaving it in Excel, I understand the point of using Excel, but is there a platform that you use to share this intelligence? Am I making sense in my question? So you're starting to gather all this intelligence. Are you repositorying? Are you using a platform that that can then be used to share this with other customers?
Yeah. There's a bunch of different ways to do it. First, what I wanted to make sure that I had was an understanding of all the threat activity that was available. And it seems to me that every company obviously does this differently. But for the atomic IOCs like hashes and again domains and MD5s, these things can be put into different formats like sticks or the Cybox kind of JSON objects that can then be read into different types of platforms. For us at Anomaly, we use ThreatStream as our main kind of indicator management platform, and you can, this enables me to upload all these IOCs, tag them as the appropriate threat level and actor association so that those can be more programmatically ingested into detection appliances and SIMs and stuff like that.
Excellent. So what happens after this then? You've got, all the data.
So I've got all this data. I've got my, my sample that I started with. I've got all this other data that I wanted to get in here that I thought was related to the same type of malware family. And basically, a tool that I and a lot of other Intel analysts use is called Maltego. And what Maltego does is it helps you take atomic IOCs or nodes, and it helps you create relationships between nodes as well as discovering new nodes. And so basically the thing I do is I put all this information in Maltego, which is, again, it's something that a lot of Intel folks use. And then I connect all these other data sources that help me explore relationships between the initial indicators.
Cool. We'll take an info.
Yeah, so I'm using Maltego, I'm using Virus Total Intelligence, VT Graph. In terms of connecting the different types of malware, one of the things you always have to do is look at kind of network data. So you always want, something that gives you domains and IPs. So I often lean on Passive Total and Census and Shodan, which are other kind of tools and data providers that allow you to kind of enumerate relationships between nodes. I use our own.
So my question,
go ahead.
I have a question, right? So you're doing all this great work. You've used all these amazing tools, and I'm sure the audience is really learning a lot. And my question now comes, I can't replicate or clone you too often, can I? Or maybe even once. How do I now share all of this insight, this intelligence, right? I understand we mentioned sticks and taxi, but how do I distribute it outward? Obviously not using WhatsApp or anything like that. What's the best way to do this?
Yeah, I think that's like a profound question that honestly doesn't really have a good answer, because it's gonna depend on the types of technologies that you have in place. But I really do believe that you have to have, one, if you're an Intel analyst, you want to build a knowledge base because you want this Intel that you're gathering to be useful and for other people to have access to it. And then you want to make sure that it's connected with more programmatically sound platforms. So you want Intel to be going, machine read and then fed into detection tools. So I don't think that really answers the question, does it?
No, I understand.
But maybe I don't really have a great answer for it.
No, that's fine.
Unless you have a threat intelligence platform to kind of centralize and curate all of this information.
So now these are all the tools you use, and then what happens after this then? So what,
Yeah, so I started connecting all the dots, and I found out that, the malware that was also submitted to VirusTotal that looked similar to my initial piece of malware was somehow related to Wet Panda. And so this was, again, me kind of getting, taking a bunch of assumptions that I had based on the data that I was seeing. One, I was assuming that this vendor or that this submitter was experiencing an intrusion. They definitely had a piece of malware that's similar to our unknown backdoor, as well as backdoors called Pisces and Backshell. And I knew, based on previous experience and the vendor information that was available, that these two malware families were exclusive to the threat actor Wet Panda, meaning when you see those, you have a good sense that it is that threat actor. And then I had another assumption that my new backdoor, the one that my customer asked me about, was super similar to Backshell. So now I've aggregated all this information, and I'm trying to make an attribution for my initial customer. So I had to do some code comparison to prove that this hypothesis was somewhat valid. And this kind of leads me into a code comparison where I said, I have a sample called Backshell, which has only ever been used by this threat actor Wet Panda. And this is, its name in the wild, this is its compile time, and this is, the configuration that the malware was using in order to call out to its C2 address. So I actually did this analysis to see how it extracted its configuration values. So you see the string there, it's looking for something with a header, its config file, microsoft.windows.bng, and then there's the command and control domain and some other values. And so Backshell has the same configuration routine as the unknown malware that we were seeing that was in my customer environment. So what I was able to do by analyzing the malware and by pulling together all these different pieces was to come to the conclusion that my brand new sample of malware that my customer was asking about was an evolution of this previous malware that was called Backshell. And that was based on Wet Panda. So what I have now is a transitive kind of conclusion for attribution that if Backshell was associated with Wet Panda and the unknown malware is an evolution of Backshell, then the unknown malware is an evolution of Wet Panda's kind of TTPs. So that's a kind of loose attribution based on, like a logical transitive property. But then we also had a bunch of other things in place where we had the naming conventions of the files, the communications protocols were similar, the domain C2 were all similar. So all of this together kind of played into, I have now a confidence that that this activity was attributed to the threat actor Wet Panda, which again helps my customer better understand the risk of the intrusion.
But a couple of questions, sorry, just two last survey questions to the audience. I think this has been really insightful. And the dark web is an important source of threat intelligence. So please do start voting. The dark web is an important source of threat intelligence. We have one other question from the audience, another one. What are the threat sources I should look for malware, and which are the tools for remediation? I think we answered a lot of these questions. You shared a lot of tools. And remediation, I think this is not the webinar for remediation. There's a lot of things you can do for remediation, but what are your thoughts on this, please?
Yeah, remediation's definitely not my forte.
Yeah, not for this topic.
I think there's sometimes there's a lot of kind of systems administration tools that you can use for more automated remediation. But in terms of looking for the malware, there's a lot of different vendor things out there that you can buy. A lot of agent-based technologies to find things that are using new and different persistence mechanisms, or maybe behaving in strange ways in order to determine if there is in fact a piece of malware on an endpoint. But I have no preferences between any of the different types of like detection systems, because they're all pretty similar in my mind.
Okay, another question, which was other than MS threat modeling, do you have any other tools that you do threat analysis or threat modeling?
Yeah, I think the modeling piece, I definitely, again, looked for, Maltego is how I would do a lot of the relationships, which is what you might call modeling. There's a big open source project called CRITS, which is a...
Sorry, how do you spell it?
CRITS, and that's on GitHub, and that's another kind of intelligence management platform that will help you model how threats relate to each other. Okay,
I do want to share the fact, because I use it myself, so I need the audience to also know about anomaly stacks, STAX, because I think it's really important, for people to try out, the platform, and there's no charge for it. But could you spend a minute or so talking about the Stacks platform?
Yeah, I think Stacks is kind of an interesting way, again, for people to kind of share and integrate intelligence, especially the machine-readable intelligence between different types of platforms. So, again, if you have one thing and you're kind of curating indicators and modeling stuff, you want to be able to plug that into other things. And Stacks is kind of a method for, helping that connection happen between different types of technologies. So I think there's a really good value there, especially when you're getting back to your previous point.
Okay, we've got time running out, so if you just go through one or two more slides that you have left, and then let's answer the audience questions. One important point for the audience: please leave us feedback, if preferable, written feedback, not just hitting the 3 stars or the 4 stars or the 5 stars. Is really good, because then we can take your feedback and improve our webinars further. Yes, Steve, over to you.
Yeah, so, the takeaway is that through all those different things, this intrusion set was attributed to Wet Panda, but it was a low confidence intrusion attribution because it's based on TTPs. TTPs only, without any infrastructure lapse. There are a couple things to remember here. Doing the attribution is one thing, but you have to be able to interpret the results to make this valuable. So if you know it's Wet Panda, you can take better steps for remediation if you understand the TTPs of a group and you're able to better kind of search for them in the environment, which some people would call like either hunting or active discovery or things like that.
Okay, I've got a couple of questions, Stevie. Let's try to answer them. Should companies become active hunting threat hunters rather than passive responders to really get in front of threats? Yes or no? Simple yes or no.
Yes, absolutely.
I also agree. I think it's a yes. They should become, but again, you need the right skills. Otherwise, you're in a major problem. In malware code libraries are reused. How is it done? Are malware code libraries reused? How is it done and how is it detected? It's too long an answer, I guess, but we can try answering this.
Yeah, that's a question of taxonomy, and taxonomy and code classification is a huge art form. And generally, I see code libraries reused all the time, especially within relative malware families. But that's a question for a different day, because that is pretty hardcore malware analysis.
Okay, we have a minute left, and I know there are still a few more questions. I'm so sorry to the audience. We should have probably made this longer than 60 minutes, but it's been really informative. So you can always review and re-listen to this. And a request to the audience, do leave us good feedback, hopefully good feedback. If you don't like it, also just let us know why that is so. So the other one, sorry, one final thing, forum.anomaly.com is the website. You can also get more questions answered by Steve and the likes of Steve. So I wanted to thank Steve and all the audience members who are listening in and who have joined in. Steve, thank you very much.
Thank you. Appreciate your time. This was fun.
Thanks. Bye.